That should have been the last talk, and my prompt is a simple one actually. I work in the Safari informatics, so I thought I'd bring a problem that we actually have and get some inputs from you. So in Safari we have two research studies. One is Spark and Searchlight. So we have a lot of participants, hundreds of thousands of participants giving us information, and we are we are trying to think about where are the applications of all the algorithms and models that you're working on. We don't have anything. We have so I can set the context for that. So a couple of problems I drafted here is one of the things that we talk about is can we predict the retention and engagement of a participant in a research study over a period of long time? Long time is about 20 years. We are already 6 years old in one of the research subjects. So and we have a lot of information about demographic information about the participants. So that's one of the problems. And we have predicted about the age of diagnosis that we have found some. We have some insight based on looking at the data ourselves, but this is not applying any kind of techniques. Is that? Do you want to discuss that, or like you want me to go? Do you guys have any?
Can you say, like, so for the participants, you know how much they participated? Like, you want to predict how much they're going to participate, but do you have for the ones that you've had so far how much they've participated?
Yeah, and so we can. So yes, we have the information. Like I said, we have the 6 years of onboarding participants and their participation in that study, and we are just entering into the next phase of that study as we gather more insights from them. So the important problem statement becomes how do you onboard more participants in the study and retain the participants that we have with their data over a longer period of time.
You
What are the methods that we have tried?
the size of the data set.
The size of the data sets for Spark is about 300,000 rows of data, about let's say 100,000 accounts with mom with multiple children and so on. So about let's say 100,000 accounts, 300,000 individuals in the data set, and and of course it's grew over the period of time. So first year, second year, we have 50,000 or so who have been in the study for 6 years. So the others are more recent entries into the study. So what does it mean? So we are recruiting them through different modes. So a couple of things that we have drawn insights into is online recruitment. Like we are recruiting them out of Facebook ads and Instagram ads. And there are others who are recruited through hospitals, clinical sites across the US. So of course, the channel of recruitment has an impact on the participation of the subjects in the study. The other being in a study like Searchlight, where is much more serious ailments. The age of diagnosis, if a mom has a child who was diagnosed 10 years ago, she knows how to live with that child. So that is a predictor of how much she's able to participate as opposed to someone who got a diagnosis last week. Then they're trying to figure out their life now. So their participation is less. These are some things that we've drawn out of from just looking at that data and drawing some conclusions out of it and testing with some methodologies after and finding out.
What was the methodology that you used? Like a linear regression or like boost or model?
Actually, we within Spark we haven't. So we've sort of outsourced this data to someone, and a couple of I think KKI did an analysis based on engagement data. The Kennedy Krieger Institute did an analysis of. I don't know what methodologies that they use, so we're trying to think about what we can use internally.
Is there like a data set somewhere on, let's say, like an internal computational resource, let's say it's Rusty or PyPy, that we can just go look and see whether, because I think that's what's gonna be important, like to foster the collaboration. Is like if this is ready and someone is bored and it's just like let's throw our favorite method in it. Is the data accessible for us?
I think that's where we want to get to. So short answer is no. Currently, no, the data is not accessible to for any researchers outside.
Within the sign,
It's in, sorry?
within Simon's Foundation, within.
It is hosted in the cloud, but it's this data is the engagement participation data is sitting in AWS mostly. So I think we want to be able to host the identified set of data within Simon's Foundation so that you can get access to like what you're talking about. I think that's sort of the next step. So you're saying so basically just drop the data there. You can try to see what emerges out of it.
Yeah, like it sounds like yeah, like if it's like we were talking about between outsourcing and we don't know the methodology and trying something like as simple as linear regression. I think once we get a hold of data, it's probably easier to understand what we can do with the data. But cool.
Basically a table. There's 100,000 entries, and I don't know how many variables. I don't know.
So again, there's the participation like email opens and logins and so on. That kind of a completion of a task or accessing a report. That kind of engagement columns that we can provide for different accounts.
But could you give one table? Because it seems to me like people would be able to use it easily if what Kay said, it's available sort of internally, because I understand probably there's some privacy issues, but if it was just one table, or is it like kind of more complicated? Because that's that will make it harder for people to use.
Yeah, I think for engagement data we can provide. We're just trying to see. So yeah, I mean I note that I was as an input one table that's de-identified and accessible with what we call as engagement, and then see what emerges from it. So yes, we have a version of it, and the version looks usually like: did they complete a survey? Did they return their genetic sample? Did they?
This sounds like a great hackathon. Like it's right. I mean, like because it seems pretty straightforward, and maybe we should have a summer intern hackathon and just see who can do the best job on your data set.
It's not. Well, it's a research study, so they are our, partners, investigators. So some people have looked at it, but yeah, I mean, if that would be, we can scrub the data and make sure that there's nothing sensitive in there and provide that. That'll be an interesting exercise. We'd love to see what can be done there. So that's engagement. A bit more, I think, Anup is here. I don't know if he has a reference to that paper. The second problem is something that is also like the IQ data. Is we work on neurological conditions, so the IQ of a participant is an important information that the researchers look for. And the IQ as an information is available in medical records. So we try to get that from the hospital partners that we work with. So for a few thousand people, we have that IQ data, but for the rest of the hundreds of thousands, we don't have that IQ data. So the problem statement is being, can we predict the IQ? And if so, how well are we able to predict? And can we release that? Can we predict it and add that as an additional information we put out to the world for other researchers to access? And in this problem statement, I think some effort has taken place. I think, Anup, do you know the reference to that paper? Anup is a colleague of mine who works on the same project.
Hi, yeah, I'm on the product team on informatics as well. There was a Columbia grad student, I think, that published a paper doing the same thing. I think the results weren't super great, or I have to reread the paper, but there's like two levels of prediction. There's like actual IQ score, and then just intellectual disability, which is like binary, like less than 70 score. And the inputs are like obviously the general account information, but there's a ton of surveys that we get. There's a lot of missing data though. Some people will have will fill out every survey we can possibly have with self-reported diagnosis stuff like my son cannot speak or these various actual clinical measures. Some people we won't have like anything on really. We'll just have their registration information. So there's like a wide variety of like depth of data for each row. But yeah, as Swami said, there's about 5,000 people where we have validated data from a like actual IQ test score. So those like the label data set, and then we have the 250,000 or whatever people that we don't have the label data for. So
soft data that there's, and maybe even, things that can't necessarily be translated to numbers. But I mean, similar to like a hackathon is a challenge, and I think the key to that is providing the data in a clear way that's easy for people to download, that's easy for people to see if they got the result that you need, that you have a way of evaluating perhaps, and then hosting an event. Maybe going to a conference where other things like this are happening.
This so, or just to get some direction for us. So if we put that data together, we can do a hackathon to see like either of the problems here internally, right? Okay. Yeah, I mean, I think we can work with whomever to see if the data that we can come up with would be usable. And I think by soft data, did you mean numbers versus? Can you elaborate on that?
Yeah, I'm just worried. Like I was imagining if I were trying to do this, and if it's really a table of numbers, it's very easy, right? I think people can go forth. But if it starts to have like missing entries, and it starts to have, little sentences and comments, like my son sometimes talks, or I don't know, then it's a nightmare. I don't know. Then I don't want to deal with it. So it seems to me if you can, like, you have two nice problems there, or maybe you start with the simpler one. You create the data set. I think that's a key piece. And now the easier it is for people to get their hands on it and to evaluate it, the more likely people are going to try to do it. And now, then you put, you have some kind of competition, whether it's a challenge or a hackathon, or so people are kind of motivated. Maybe there's a prize. I don't know. Yeah.
The missing data is going to be a problem definitely, because like we have hundreds of thousands of accounts, but you are going to have.
I mean, that is something that is a little more people know how to deal with, but
okay.
But it's the fuzzy data that's going to be tough.
To follow up on Lisa, so I totally agree. Like I think three, obvious options. So one is either keep the data internally and make them available, and there are crazy people like Case who actually already was like, oh yeah, these are the data, I'm happy to look at them. Or organize hackathon as Lisa said. Or there are platforms like Kaggle, or where you really publish a data set, and people are also crazy enough to just test their tools on that. And third option, obviously, so it looks like you have lots of awesome data, and maybe a data scientist would be someone really useful to just hire and to have like professional insight and help. So, I mean, I think there's lots of interesting questions you can ask, and those two are super nice, but probably it's not, so there are many options, I think.
Thank you.
We should go on to the next open problem.
I think I will close, and I will make it really short. So maybe what we can do, if anyone is interested, just please find me, because it's 10 minutes, and we all want to grab lunch. Can you please? Yes, this one. Thank you. Okay, so the problem. So the slide shows the problem, but I will start with motivating. So I already showed you in my slides before. There were spin models, right? So there were spins pointing up and those particles are sitting in various ways. But how we build it in the lab, and this is where true magic happens with novel phases, and we want to understand what's going on. you have actually, we have a space in your lab. It's usually, you can imagine it's a 2D grid for like a discretization to focus attention. And then in the end, for example, you want this shape. So have your balls in specific places in space, but when you're loading your atoms to the plane, it's completely stochastic. So you start with any possible combination of that. Usually you have filling of 50%, and then you want these. And the problem seems pretty simple, and when the system is small, you can use deterministic models. And what people use right now, they have outside of the lab, in a like separate computer, they compute every possible. So if you land like this, you have a lookup table that tells you take your tweezer and you move your ball there, and then you have a lookup table for every position in your table that shows you the path of your grabbing tool that moves your atoms around. The problem is that when your system increases and we want to go for 100 by 100 or 1000 by 1000, storing lookup table is absolutely impossible. So this basically blows up your memory. So the aim is to be able to tackle 100 by 100 like systems like this. And the training can be super long, and that's not a problem. But inference has to be below like 1 millisecond, and it's already pretty generous. So maybe it's not about machine learning here. Maybe you have optimal transport or something like this that could map one to another. But the clue thing is that inference has to be super fast, and this is what we would need.
With that type of scale, optimal transport is perfectly fine.
By scale, you mean what?
100 times 100.
Oh, okay. And then how do you? What kind of input do you need to train?
So I think what you should have is how to map the left grid to the right grid, which is a distribution you want to map with. So you will have a transport cost from each ball to the destination it should go, and you choose the cost that minimizes transport.
And can you do so? You cannot pass through the atoms. Is it okay with optimal transport or not? You're moving in this 2D space. This is a problem. So you cannot do like.
Yeah.
But you're allowed to get rid of balls, so I think it's like a multiple stage optimal transport problem, because you can see like the occupancy on the right and left is not the same. So you need to first decide like which ball is optimal to get rid of. Then
Yes, you can also do that.
transport.
Yeah.
Okay, so you say Google multi-stage optimal transport.
What?
Multiple stage optimal
I
transport.
don't know whether the first stage is multiple side transport, but yeah,
Okay.
it's one of these things that sounds trivial, but it's made me a little bit more thinking.
Yeah, I think you should just take optimal transport, but with this weird distance that you have, because it's not Euclidean distance, it's like Manhattan distance, something like this.
Yeah. Mm-hmm.
So yeah, I think it's possible, I guess.
Okay, and then inference with optimal transport is fast, or because this is something I also don't.
It depends on the size of the system you want to do inference with. But I think we can work out something. I think it's possible.
Is it like the time requirement is an algorithmic thing, right? Like whatever you can.
Yeah,
you have like some special device that just compute that. And
there is no training in optimal transport. It's just like compute the distance. So.
Okay. Also, the other thing is, so we don't need optimal path. It's just any path will be fine.
Yeah.
At this point.
We can use sync or not. Yeah.
Okay, great. Then let's. If someone has any insight, awesome. But I will try to contact you later. Okay, then naturally we're concluding. So thanks a lot for being here. Thanks a lot to Ruben, Case, Lisa, and Siavash for organizing. And I hope you enjoyed that, guys. And thanks a lot.